is going on, folks? How you guys doing? Alright, well, here's what we got today. I want to talk about some differences in tuning, different types of tuning, and just some variations on different things. So, if we're looking at motorcycle tuning, most modern motorcycles are what's known as speed density, okay? What speed density means is it uses throttle position, it uses engine RPM, and it uses a map sensor, okay? So that map sensor is manifold absolute pressure, which what that means is it tells you what the intake manifold pressure is. Now understand that if it's a naturally aspirated engine, meaning that we're not turbo or supercharged, then that intake is actually vacuum. It's a negative pressure, not a positive pressure. But, that's where it is. It basically goes from atmospheric pressure, when the throttle's wide open, to negative. And even wide open, it's technically probably just a hair under atmospheric, but either way, it's a negative pressure. Now, when we're talking about boosted stuff, sure, we start to see a positive pressure on that intake. But even though we're calling it manifold absolute pressure, it is a negative pressure, okay? So it uses that to determine engine load, okay? That is basically, you give it a throttle position, you let it, achieve whatever RPM, and then, well, how much load is on the engine? So here's what you have to think. When you're climbing a hill, there's more load on the engine, and therefore it requires more fuel. If you're going down a hill, there's less load on the engine, and therefore it requires less fuel. Now, you can be at the same throttle position and the same engine RPM in both conditions, but load has changed. And if you think about what a road looks like, I'm in Texas, and it's about as flat here as it can get. But it's still not completely flat. The road rolls up and down. Now, if you're in other parts of the country where it's a lot, more undulating ground, then, obviously your load is going to change even more than it does around here. But here, it still changes a lot. When you actually watch that map sensor live when you're going down a road, you'd be amazed just how much change there is. Just a tiny imperceivable change of throttle position makes a huge difference in load. So, and that's pretty much in motorcycles, that's the most advanced system that they pretty much use. Now, in automotive applications, there's what's known as MAF, or mass airflow, okay? And it uses mass airflow, it uses MAP, it uses throttle position, it uses RPM, and it adds another basically access to the way it decides what's happening. In a motorcycle, so far, I have never seen a MAF sensor installed, okay? You have to have a long intake runner, and you'd have to have somewhere long enough to put that in. And it's just really space constraints, it's not there. So at this point, I have not seen a MAF-based tune. These are MAP-based, which is speed density. Now, there are some tuning strategies out there known as Alpha N. Okay, Alpha N uses throttle position and RPM only. It doesn't know what its load is. It has no idea. So it's going to deliver the same amount of fuel going uphill as it is going downhill, which could be an issue or not. It depends on where it was set up. It's obviously an issue either going up or going down, but it just depends. And again, remember that we're not driving or riding completely flat. We're going up, we're going down all the time. So that fuel requirement is changing based on road conditions. Now, Thundermax is one of those tuners that has gone to Alpha N. They went to it many years ago. It's actually reverting back to, as I've explained, sort of an older style, an older way to go. And that is the reason that those Thundermax units have wideband O2 sensors installed, because they're trying to cover for an axis that they took away. If you're using speed density tuning, you don't really need the O2 sensors, because you know what the load is. And as long as you calibrate the map properly, then at any given manifold pressure, throttle position, and RPM, you can determine what that fuel requirement will be, what the fuel mass requirement will be, and therefore you can replicate it over and over again. Okay, now with a ThunderMax, that Alpha N system, with those sensors, with the wideband sensors, basically what it is doing is it is seeing itself go lean, and it is adding fuel as needed when it sees itself go lean. When it sees itself go rich, it pulls fuel. Okay? Now, that basically means that it is always chasing. It's always adding and taking and adding and taking and adding and taking. And if you ever look at the differences in a dyno graph, if you really scrutinize them, you can tell a ThunderMax tune from a speed density tune. And I'm not trashing them in any way. It's just I tune a lot with both systems, and I can tell the difference in the way that it prints and the way the engine responds. It will typically hold a more consistent air-fuel result with speed density than it will with Alpha N. And, that's kind of funny because we think, well, we use ThunderMax and units similar to that for force induction tuning, this in the older bikes. Now, in the newer ones, we use Impact ECU, which is something different. That's modern stuff. Still, it's speed density. But it does have widebands on it, and it's kind of the best of both worlds. But, just to kind of give you a feel for the differences here, that's basically the differences in what's happening. Now, on the newer bikes, so I think 2017, I believe, is when we first started to see the torque tables show up. And so typically how it works is most of these bikes are electronic throttle. So when you command a throttle position on the handlebar, it tells the computer tells the throttle body to give you a throttle blade angle. And with the torque-based tuning, that's not what's happening. Okay, that is not what's happening. On the torque-based tuning, there is a torque commanded table in those, meaning that it is shooting for a torque target. It is trying to output a torque value, basically a foot-pound of torque. It's what it's actually shooting for. It's not just giving you a throttle position RPM, which is why if you've ever had one of the newer bikes with what they call RDRS on them, which means that you have a TC, a traction control button on your bike, on the Harley specifically. Basically, those bikes are torque-based tuned, meaning that it is shooting for a torque value. If you exceed the limits of traction, then it will actually reduce torque, and it will keep it from spinning as much, or it will take the spin away. If it starts to spin, it'll close the throttle or pull timing or whatever it needs to do to reintroduce traction. And it also integrates, on those systems, it integrates with the braking system and a few other things. But, as far as the engine performance goes, that's what that RDRS system does. It is torque limiting. So if you've ever had one of those bikes and you have it sitting in neutral and you blip the throttle and you want to rev the engine, you'll notice that it doesn't rev the way that they always have. It won't just rev to the rev limiter or respond aggressively. It will just barely bump off idle. But you have to understand why it's doing that. So the reason it's doing that is you're in neutral. It doesn't need any torque to achieve, it doesn't need any serious throttle blade, is the way to say this. It doesn't need any serious throttle blade angle to achieve the RPM and torque value you've commanded for neutral, because neutral doesn't need torque. Now, if you put the bike in gear and blip the throttle, you'll notice that it suddenly gets more aggressive. It's still not as aggressive typically as a bike that is tuned to just respond on the throttle blade. So, where you're actually choosing a throttle angle. But you'll notice that difference in those bikes. That's why they act that way, and we get a lot of questions, as to why they do that. Now, obviously, when we tune engines, we tune some high performance stuff that makes, double or 3 times or more what a factory Harley engine would make. So we have to recalibrate those torque tables because we make more torque easily at a light throttle than the original engine ever would have. So we have to increase those values to command a higher torque value. So, and also we can affect how the engine responds when it loses traction and so on and so on. All of that stuff is adjustable. So, hopefully that gives you guys some insight as to what's going on and what's there and what's not. And, like you hear a lot, especially with the Thunder Max, people say, oh, it's got, it's got wide bands on it. It's awesome. Well, it sort of is and it sort of isn't. The wide bands are there because they're fixing an axis that it took away, which was a map sensor. With the map sensor, you don't technically need those wide bands. Now, if you want to use like an impact ECU on the newer bikes, 23.5, 24, 25 model bikes, and he's going to have a unit coming out here soon for the older bikes. But those things, those are speed density with O2 sensors. So that's a bit closer to like modern automotive type tuning. So, again, not MAF based, it's not mass airflow, but this is why we have to tune these bikes when you change anything about the airflow parameters of the engine. If you change how much air can actually flow through the engine, then the targets and the models and whatnot that are built in that engine control unit, that ECU, they're no longer valid because the engine flows, hopefully, a lot more air than it was factory. Let's hope we've done it and made it better than original. So now it flows a lot more. So, but anyhow, hopefully that gives you guys some information. And if you have any questions or concerns, feel free to reach out to me in the shop, or you can always send me a private message. So, all right, y'all, take care, and we'll see you out there. Never forget what's important.